Thank you, Promise, for letting me run the session now. Once again, I'm Sanam Serchan. How many of you guys believe this is true?
Well, it's good, yeah.
Everyone?
Yeah.
Okay, so today we'll try to learn at least few things that might help us to reduce at least few of the bugs which might happen while we're writing code. So we'll go through these agendas today. From introduction, we'll look into the basic types. What are the types that are in TypeScript? Okay, maybe let's hold on for a while. All right, let's start again. So, for those who just arrived, this is Promise. He's running the show today and next week, and I'm Sanam Serchan. I'll be doing today's session about this basic TypeScript. And this is the agenda for today's session. So we'll go through basic types. What are the types in TypeScript? We'll look into the annotation and inference. Then we'll see some of the features of TypeScript, for example, union types, how you can create a type alias or interface. We'll see the difference between those two, interface and type alias. We'll look into enums, and lastly, it will be about the utility types. So let's get started. So how many of us here has worked in TypeScript before? All right, at least a few. Okay, that's good. So anybody can say what is TypeScript?
TypeScript open source for check the type error.
Yeah. Okay, that's good. For now, let's see what is TypeScript. This is TypeScript. Basically, it's a superset of JavaScript. So it is not a new programming language. It is nothing new. When you're writing TypeScript, you will actually feel that you're actually writing JavaScript code itself. The only difference is that we'll be giving types to maybe variables or parameters and objects, anything, right? So at the end, we're not moving away from JavaScript. We still need to learn the fundamentals of JavaScript to be a good in web development. If you want to write TypeScript, you still need to know JavaScript. So today's session, I'll be talking about types, a lot of types. So you might feel that I'm saying too much about type word. So yeah, this is, as I mentioned before, it is a superset of JavaScript. The second point, it is strongly and statically typed programming language. We know that JavaScript is dynamic language, right? When you define a variable, you can assign another thing. For example, you say it's a string, but then you can assign a number, you can assign a boolean, you can assign anything to a variable in JavaScript. So that's dynamic programming language. But TypeScript, if you define a type, say that there's a variable called name, and if you want it to be string, then you cannot assign a number or a boolean. You cannot pass any other type. So type is basically, it refers to what kind of thing that a value can have. Can it have a string? Can it have a number? Can it have a boolean? So that's mostly type. But at the same time, I've mentioned that it's optional type. And that's because, coming back to the first point, TypeScript is basically JavaScript. Yes, it allows us to strongly make your code to be statically typed, but it's not compulsory. You can still write a TypeScript code without types, so that's optional, but it's always better to give types. And the way I see it is, it's just another tool to help you write more robust code. For example, when you're installing, if you have installed extensions like prettier to format your code automatically. So that's an extension that's kind of like a tool that helps you that helps your code to be formatted in a consistent way across multiple colleagues if you're working in a team, right? So it's kind of like another tool that, yeah, as I mentioned before, helps in this kind of things about code quality. We'll see more about this. So why TypeScript? The first one is again about maintainability. So there's a when you, especially when you're working in a team in a company, there's a very high chance that if you're just working with JavaScript, there's a high chance that you might not know what kind of parameter or function parameter is expecting, or you write a parameter or function with a parameter to be a string, but then someone from your colleague passes a number and then that breaks your code, right? So there's a that's one of the main reasons. So it can help you in maintaining your code, better error detection. Stronger collaboration is about your code becomes like a self-documentation. You don't have to, if you have ever worked something called JS doc, you can actually mention right above your code saying this function is taking 2 parameters, the first parameter has to be this, right? You don't have to write all those things. Your TypeScript code automatically becomes like a self-documentation, and that enables strong collaboration. And in installing, we'll see about that, how it can help you to write, how it helps you for the productivity as well. So Stack Overflow does survey every year about different things like most popular technology, most loved, and as you can see, TypeScript is in number 5, which is very good. That's why, if you're in the web development space and if you're learning JavaScript, then TypeScript is something very beneficial to learn. And at the moment, it has become like a standard de facto if you're working in the company. Like every company now uses TypeScript, so it's always good to learn it. So now we'll jump into TypeScript setup. If you haven't, and if you want to follow up along the slide, along the session today, and by typing yourself, trying out yourself in your local computer, then at least you need to have Node and npm installed. Then there are different ways of installing TypeScript. You can do it just locally within a project structure by using packaging, but today we'll be just doing it globally. So the first step is to install TypeScript globally, and then once you install TypeScript, the browsers or Node, any of these things, they don't understand TypeScript automatically. They only understand JavaScript. So this is where TypeScript compiler comes. TypeScript compiler, what it does is it compiles your it takes your TypeScript file, and then it compiles that into an equivalent JavaScript code. Then that JavaScript file is what is being understood by browser or Node. So that's why we need TypeScript compiler. So when you install TypeScript, then you get something called TSC, which is short form for TypeScript compiler, and the way we run it is TSC and then the name of the file, and that compiles your TypeScript file to JavaScript. And to run it, it's if you have ever run JavaScript file, for example, node index.js, it's very simple. Then we run that file. And the configuration is about now, if you want your TypeScript compiler to behave in a certain way, then there are multiple options that you can give to a TypeScript compiler, which is usually tsconfig.json. So this is the file where we'll be usually having all those things. For example, these are some of the very basic and popular ones that we usually have in our project. For example, outdir, which stands for like out directory. As if you have heard, as I mentioned before, TypeScript compiler compiles your TypeScript file to a JavaScript. But what it does is it generates that JavaScript file wherever your TypeScript file is in the same location. But if you don't want that, and if you want it to be in a certain place, for example, the most usual place is like build or out or dist, which is for distribution. So you can mention that in outdir. Target, if you want a specific version of JavaScript, for example, ES3, ES5. Similarly, we'll look more into a few of these later. Again, this is how TypeScript TS configuration will look, and these are the basic things like module. What kind of module are you targeting? Source map. This is it is useful for debugging mostly. If you want your JavaScript file to be mapped back into TypeScript, this is what's used. Yeah, strict. We'll look into it more later. All right. So basic types. TypeScript supports all the types that JavaScript has. So that means all the primitive types, for example, begin, boolean, null, everything, right? And the way we would give a type to any variable is simply colon and then saying, is it a string? Is it a number? Is it a boolean? Or besides the primitive, you can also have types, for example, array. So how you would do array is just like string and then empty bracket. There's another way of first saying array. We can look more into it later. Angle bracket and then saying, is it a string or a number? Another type is date. Right, so let me right. So as I mentioned before about so if you look at this line number 58, what I've said is I want all my JavaScript files, TypeScript files to be compiled, and then I want it to be emitted into this folder called dist. So even though I have all my TypeScript files under source directory, it will now go to dist because this is where I've mentioned. If I want it to be something like another folder out or build, then all I need to do is I just need to specify that location here. So just to show that, for example, let me create a new file here saying main.ts, and right now you don't see that main.js file being in that dist folder, but once I do it, because I have that TypeScript compiler running here in my terminal, now you can see this main.js file. So when we created a main.ts TypeScript file, our TypeScript compiler compiled our TypeScript code, even though we don't have anything, that's why it's empty right now. But if I type something, for example, let's say lit, and then I say my name to now if I go to main.js, okay, let me say my, see, okay, first of all let me give a type here. So this is a basic TypeScript code, right? You're defining a variable, you give a type saying string, and you pass and then you assign a value which is dented code in a bracket. What do you call this? I forgot. Quotation, yeah, thank you. And so that's a string, right? And then if you look at it, as I mentioned before, TypeScript is nothing, right? It's JavaScript. So this is what it looks. In the runtime, even though TypeScript helps us to check a lot of types during the compilation while you're writing the code, once it's compiled and then when you run the code, you're actually running JavaScript. So you don't see any types here, right? We don't see the colon string here. Now, if I try to say pass a number here, this doesn't allow me here because we said that my new name should be a string. Let's do the similar thing by removing this now. It still doesn't allow because it's it's supposed to be okay. I was supposed to say this on the slide, but anyways, even though I removed the colon and then string, right? It still says that string. Why? Because TypeScript is smart enough to know the type from the value that you have provided. So this is what is inference. Inference is basically, is understanding something based on some of the facts. So since we have passed a string, which is standard code, TypeScript will automatically know that this is a string, okay? And then in the next line, it doesn't allow us to do, it doesn't allow us to pass any other types, for example, number or Boolean, nothing like that. Okay, so just showing you how TypeScript compiler compiles and then does the that thing. Now, let's start with, basic types. As I mentioned before, so there are number, string, Boolean, date, and array of string. So we have a function here which is add two numbers, and at the moment, if you hover over it, we haven't provided any type to this two different parameters a and b. So that's why it has a type called any, right? And if I now try to call this function add two numbers and then pass a string, it still takes that number because we haven't provided any type to it. So this is our most usual JavaScript code that you would write. Again, even though it is a TypeScript file, as I mentioned before, we can still write JavaScript code. Now let's see how we can actually provide types. So what we can do here is, let's say, since we're trying to add two numbers, a and b, so we know that a and b should be a number. So I'll go colon and number. Now, as you can see here, we instantly get that error because string is not assignable to a parameter of type number, right? So this is one of the benefits of TypeScript. So I'll remove this, and now again we get error in the second parameter because we're still trying to pass a string. So I'll remove this. Now TypeScript doesn't complain at all. I'm running Node1 here just to see the but it's a bit weird. Should have added 1, 2, 3, or maybe I didn't save it. Yeah, now you get the 246. Because before it was returning 1, 2, 3, 1, 2, 3. That was because it was concatenating two strings. But now that we have provided types and we have provided two different numbers, it's returning the our actual added result. Right. So this is a basic example. A way of how you would use TypeScript in your JavaScript code. The next thing is about, in a similar way, we can do not just number, string, Boolean. It's very similar, but I wanted to talk about any. So right now, since we haven't provided no any types, it automatically becomes any, right? So what happens? Actually, maybe let me find no implicit any. This is false at the moment. So what we want is, we want the TypeScript compiler to complain us that, hey, there hasn't been any type assigned to this, please do not do it, right? So if I go here and now say true, now you can see that the TypeScript compiler automatically gives us warning and saying that it has any type. You cannot do that. So this is one of the ways how you can configure your TS configuration file based upon whatever the preference you want in your project or based on your team while you're working with others. So now, for example, but for now, let's revert it back. Okay, so transform text is a function which should transform given a string. It can be, for now, we're just trying to make it, transform it to be uppercase. That's why when I pass hello, you can see everything in uppercase, hello. But what if I do 1, 2, 3? It's crashed, right? This is what happens when you're writing a JavaScript code. This is how we would actually write a JavaScript code. Because in JavaScript, we don't define any type to any parameters. And you never know. I mean, this looks very simple, but in real applications, when it's a big applications, there's a high chance that you actually miss giving the right type. This is a very common thing, right? So this is where TypeScript comes, and then we say, you know what, it should be string. So now I'll say hello, then it should return me hello. So this is why we shouldn't, I mean, there will be sometimes few scenarios when you're especially working with third-party APIs. You don't know what the type is. So in that case, there might be a chance, there might be a time when you might have to actually use it, but a lot of the times if you're writing your own code, using any is very strictly not recommended. So talked about this. Okay, so we'll also look about now object types. What is object types? So this is a basic object. I should be passing here number. This is a normal object, right? We then two keys, ID and name. So ID is a number. If I hover over it, TypeScript is automatically smart enough to know what the type of this key is based on the value that you provide. Name is a string. If I hover over it, you can see now the type of the object, which is object1, and the ID is number, name is string. So that's the object type. Let's say we want to print our information. I have a function called printYourInfo, which takes name and age, and then we're doing a normal console log with saying, hey, my name is this, and I live in, it should be my age is, yep, so this is my age. And here I'm passing the right information with the first name to be a name, with the first type to be a name, which is prem, and the second parameter to be 20. But this is also another place where you might actually get bugs, because now, especially when you're working with third-party APIs, you don't know if you're supposed to send name in the first parameter or in the second parameter. What if I send like this? This is still valid, right? Because we are passing two parameters. We're not checking, we haven't specified any type. We're passing two types. That's TypeScript is okay. But now you can see, hi, my name is Ronnie, and my is something different, right? So this is one of the another issues that you will often end up while writing JavaScript. So what we can do instead is that either, as we mentioned before, you can give a type and say this has to be this and this has to be this. So in this way, you will know that you're passing the right values. Since this is complaining that the second parameter should be a number, right? Oops. So everything's good so now, but even more than that, another way, or even the better way to actually do it is, what I'll do is I'll take this whole thing and make it as an object, very similar to this one. So if you see, this is an object with a curly brace, and then we are passing the ID and name. So I can do the similar thing here. Right, so first I make that as an object, and then now I can destructure whatever I need from here. So TypeScript is again smart enough. This is not just TypeScript, but also with the the new modern IDs are that helps you to identify these kind of things. So from here we can use only is and name. So if I do is, let me do name first and then is. Now this becomes an object type. So the way I would use it now is we have to pass an object. We're not going to pass two different parameters now, because this is expecting whatever you pass, it has to be an object with a name, with a key as a name specifically. You're not just passing prem and toddy. You have to mention it as a string. So in the beginning, the way I would do is, for now, is just copy this and paste it here, and whatever the name I want to pass, say promise, and then this should be comma, let's say 25 for now. And that's how you pass an object object type and use that to be and the benefit of this is, even if I first mention put is first, it doesn't matter, because we're specifically providing values to some certain keys. It could be, for example, is has to be this and name has to be this, right? So this is how you use object types. I think that's all for this one. Let me go back to this. Annotation and inference. I actually covered this again while showing the demo. Annotation is about whenever you mention your parameter to be of type something, that's basically annotation. If you're saying member1, for example, one of the parameters, and saying colon and then giving a type, then that itself is a annotation. You're basically a process of defining, giving a type to a variable, then that's annotation. I mentioned before about inference. TypeScript is automatically can infer a lot of the types by itself, so we don't actually have to define inference for some of the things, like for this one. We can, however, do this and say this has to be number, but then we don't actually have to do this for this kind of, when you're actually defining and directly assigning a value, then you don't have to do always. This is, TypeScript is automatically smart enough to do that. So that was about annotation and inference. About annotations, we already saw that you can do either in variables like this, you can do in function parameters like this, and function return type annotation is, you have a function called my func here, based on, because you're adding two numbers, so the return type should always be number. In JavaScript we don't mention this thing, but in TypeScript what we can do is at the end of your after assigning this the parameters, and you can mention that I want this to be a number. So the benefit of doing this is, let's say you want this function to return a number, but then you write a lot and lots of code, and somewhere you end up with some bug, and that actually returns a string. Then you will what happens is TypeScript now will complain that, hey, your return type should be a number, but then you're returning a string, or you're returning a number, you're returning a boolean or some other types. So this is useful in that case as well, for the return type annotations. Now let's look about union types. We saw that we can assign a type to a variable, but union type is about some variables could have multiple types, not just a number or not just a string, but they can actually have, maybe that can have number, string, or even a boolean, or even a dead. So this is where union types come in. And the way you would use it is with vertical pipe, which is this symbol, this vertical pipe. So you define a variable and then you can say it shouldn't just have a type of number, it can also be a string. So there you go. That's union type. I think we don't have much on type union other than that. Yeah. So I said is to be a string or a number, and now I can pass both of the values. Before we saw that when it has to be, when it would be something like number, then it would complain us saying that you're not able to. I don't have the remote. Sorry guys, 1 minute break. Thank you. Okay, let's continue. So so with the type union, by using vertical pipe, which is this one, you can mention, or you can say that the value or any parameter can have multiple types. For example, this value can have a string and number again, and then when you're calling that function, you can call it with both of this string and also number. So literal types, with literal types it's the similar, you're using the vertical pipe to say multiple types, but then what you're doing is you're defining some specific constants rather than the just saying string or number, because you know if we see favorite color has to be one of these values, it could be red, blue, green, and yellow. Then you can also use some specific or constant values like these ones. So it doesn't always have to be limited within just the generic or the primitive types. You can also mention your own constant values like this. Right, so now we'll look into type alias. Type alias is useful when you want to reduce code duplication. We'll see about this, how it's actually done. But for now, the way or the syntax to use it is basically you need to have a keyword called type on the front, and you give a value, you give a name, for example, my type, and then now what you're doing is you're creating a new type. It looks very similar to how you would do how we do it in the previous slide, how I showed you about the union type. It's very similar, but then what we're doing is we're actually creating a type definition. So to see this in example, here in the again from the previous example, we said that a variable called is should be either string or number. Again, we said a phone number can also be a string or number. Then we said that in this function called log either, the parameters should be a string or number. You see, there's a lot of code repetitions for this union type, which is string and number, because all of these can be both string or a number. What if we create a type for this? For example, type. So the way we would do is first give a keyword called type, and then say I'll say new. Sorry, I think I've already written here. No, okay. String or number is equal to. Then I'll copy this. So I created a new type alias, and it basically means that this is now a new type. This is similar to how you would say age should be a string, but then what we did is we gave this exact same thing, a new name with a keyword called type. Now we don't have to keep writing this string and number everywhere. See, all we can do is now we can assign that type to another variable, and then this still works, because at the end this is nothing. We're not creating a brand new type. We're just giving an alias for this one. And similarly, I can use it here. Oops. And I can also use it here, right? See, so for example, now the benefit is in the previously, if I had to say all these things should also add boolean, then I would have to go and then change that in here, over here, over here, right? Because that's where it was being used. But now having a benefit of one type alias is you change at one place like this, and then it automatically gets inferred at every place. So this thing can now accept, for example, phone number can also be assigned as a boolean. So that's how you use type alias for primitives. For a type, for example, this one, this is an object with some of the keys. Now to create a type alias for this, I mean, why would we use type alias here? Let's say we have a add student function that takes an student object, and then it calls and fetch API in the data fetch endpoint. What we're doing is we're making a post method, post request, and then we're passing a student. So now I've called student 1 and student 2. And database or the backend, what it expects is at least some of the things. For example, ID, name, address is enrolled subjects. But right now, this is obviously a JavaScript code, right? So what if I remove this? And it will still work, right? This is how we would write a JavaScript code. Even if you missed something, we won't catch that error right now. The way it would work is we actually make a request, the backend will then fail because we're supposed to be sending subjects, but we're not sending subjects. So to catch that kind of box earlier in the process of while you're writing the code or in the development process, what we can do is we can instead create a new type. So again, the same thing, type, and then you give a name. For now, I give a student, and then the way the syntax is equal to, and then basically the same thing as here, but then now you say, okay, I need a new type called student, and that should have all these values. Now if I take this, actually let me put it here. Right, okay. So what I will do now is I want this to be strictly typed, all these objects. So if I come here and say I want this to be a type of student, see, we instantly get the error because this type alias student that we created also expects us to have a key called enroll date. But if you look at here, we're missing that thing called enroll date. We're missing that key, right? So we instantly get that error right now in the development. So I can come here, enroll date, and then I can say new date. Let's say, and now we don't get that error anymore.
Also, we can put optional, right?
Yes, that will come later. But since you mentioned it, what we can do is now, let's say, again, as you mentioned it, this student, not just to student 1, but I want it to be typed here as well. Again, it's already complaining here because what it's saying? It's saying that string is not assignable to type boolean. So if you go back and look here in your type, is enroll is supposed to be a boolean type. Either you can pass true or false, but then since here we're passing false, but then it's a string. So now, since TypeScript already gives us that error in our code itself, that's passed, but then we have other errors, which is so out of this type ID, name, enroll something, some of the things are missing, and that's enroll date and then subjects. So for now, let's do this, and I'll say networking. Now we're missing enroll date, but as you mentioned, let's say enroll date is not something that's compulsory. If someone assigns it, that's fine. If not, what we can do is we can say we can use question mark, and what that means is out of this type, all other will be required. You have to pass this value, these keys, but then enrolled date is actually could be a date, or it can also be undefined. You don't actually have to assign this enroll date. So you can see over here as well, it's a date or undefined. So now, even though I haven't passed enroll date here, we don't get that error anymore because we mentioned that it can be optional, right? So this is yeah. So again, not just to each objects that you created, you can also do the similar thing for this parameter, saying that this function should accept a parameter, but it should be of type student. Now, the benefit again is if something was let me show something here. Yeah. So let's say somehow we haven't given a type for that student 2, right? But then we have a function called add student which expects the parameter to be of type student. So this is where we get the error now, because again, it's complaining the same thing, that is enroll is missing. So we can go here and then revert it back, and now this is happy, right? So this is how you use TypeScript type alias in primitives. You can do it this way, and for objects, this is how you would define a type alias. Basically, type the name is equal to, and then this structure. Okay, so the next one is thing I don't need to present, but interfaces. Interface is very similar to type alias, except interface is only for objects. As I showed you before, type alias, you can create a type definition for primitives, for example, string, number, all those primitive types, but interface is solely only for objects. So it defines the shape of the objects, how an object should look like. Again, the benefits is the similar as before: reduces code duplication, acts as a single source of truth, all those things. And the way we would use is starting with the keyword called interface instead of type, and then we give the name, and then we defined what kind of keys or members it should have, and then the annotations. All right, let's look again into it. Very similar to how you would write type alias. So we have interface. This is the keyword that defines that this is an interface, and then a name. So we won't have is equal to like in type alias, and then we directly now have this structure so of an object. So there's this object should have a member one, and that should be some type, string, number, or boolean, anything like this. And the way we use it is very similar. Now we define a variable called myVar. We give a type annotation saying this should be my interface. And the benefit of doing this kind of things is with the tools like VS Code, it's smart enough to actually suggest you what are the keys or what are the members for this my interface. So let's say this is a third-party interface. This is coming from some third-party tools or libraries or packages, let's say. So you don't know what are the values that it expects, right? But with the help of VS Code, then you can instantly know it expects member 1, member 2, and member 3. And it also gives you what type. So you can see boolean here. You can see number at the end over here, right? So this is the benefit. Again, as same as before, if this was somehow the optional, then the question mark, this means that it's optional now. You don't actually have to give value. So member 2 passes this, and it's happy now. I don't have to pass member 3 because again, that was optional. Right, so in relation to the very similar example as before, we have student 1, student 2, and the way we use it is very similar. Instead of interface, instead of type, we will have interface keyword. We give a name, and then this one is very similar like before, and now I can pass this here saying student 1 should be of type student, and we instantly get that error saying some of the things is missing. So let me write enroll that that again. Now this is happy, right? Similar thing let's do for student 2. Again, we're getting that error because the string is not assignable. So let me remove this, and let me fix the subjects as well. Physics, for example. What's missing? Enroll that. Yeah, again, let's do optional for here as well, similar to type what we did in type alias. And now this is happy. Update student, again, you can use the interface that we just defined, which is student, and now it's complaining because it's in body. This is different. This is not a string type. Student is not student body. Int, null, or undefined. What did I do here? I didn't see this. Actually, I think this is not how you probably use it. I might have done something else. I think I need to JSON.parse. I think I need to do JSON.parse or something. Yeah, but anyways, that's fine for now. This is not actually related to here. Probably I missed something here. Okay, so I'll see later for that one. Now we'll see what are the differences between interfaces and type alias. So the first difference is the syntax that we saw, how we would use a type alias versus interface, example type versus interface. The second difference is about primitives versus object support. So type alias can support, you can create a new type definition for primitives like string, number, all of those things, but interface is solely for objects only. You can use that for defining the shape of objects. Extending, we'll see that again in the code later. You can extend both the interface and type alias. The difference is how you do it. So for example, in type alias, we use something called intersection, that's ampersand. Whereas in interface, we use extends. Open versus closed. This is about type alias is closed. So what that means is if you create a type alias, and then after that you can't create another type alias with the same name. But however, that's possible in interface. You can have two interfaces with the same name. So we'll look into that in the code again. And better error message is in interface. I think, yeah, that better error message was about. I saw this in TypeScript official documentation, but I still need to check how it actually does that. So, but for now, let's see. This should be 5, I think. Yeah, 5. Yeah. So we have already seen about how you can use type alias and interface and the syntax to use it. So these are just examples. Type, you use the keyword called type, give a name, and then you can pass. You can say any kind of types, for example, string. Or you can say it as a union type, which is number or string. You can also do a tuple, so in the bracket, and then you say number or string. Function. Better at the last? Yeah? Okay. Yeah. We already looked into defining the parameters for the, giving a type for the parameters for a function. That's already done. We looked into type alias for an object, right? So basically for this object, we're saying that these keys should have some kind of types. You can also do index signature, but I think let's not cover that for now. Okay, so yeah, this is interface again. The difference from before was how you would have type, but now you have interface, and you give a name. This contains is equal to, you need to have is equal to, but then in interface you don't need that is equal to. That's the difference. Another difference that we saw in the slide as well was about primitives versus object support. We just saw that. Okay, extending. Let's say it's not very common. I have actually, at least for me, I haven't seen much using in TypeScript. This is mostly, I think, in C#, that comes from the way of saying I for interface and T for types. But this is not very common. But for now here, I've just written it to actually identify that this is a TypeScript. So this is an interface. So let's say for this interface, we already have some of the keys here, right? What if there's a new object, and we want also that is, let's say, a new student, and that also should have a new key called contact number. one way we would do is probably come here and say contact number, and then we assign it to it. But let's imagine that this interface is used in so many places, right? You have to go in wherever it has been implemented, and then you have to add now contact number. Or you could maybe do optional, as we looked before, and then maybe we don't have to assign to a contact number, and then we can assign to only the places where we need it. But let's say this contact number is needed only for some kind of special students. We don't need it for all. So this is where extending comes in. What we can do is we can create a new interface, and so we give a new interface called new iStudent, and then we use the keyword called extends, and then we extend this keyword, this interface, which is iStudent. And now I'm defining whatever the extras that I need. So the benefit of here is, say, I don't have to, okay. So now let's say student 5. So if I assign to, let's say if this student doesn't need contact number, then I can do iStudent. And if you look at here, these are the things that it expects. So there's no contact number, but let's say this student 5 is actually some kind of special student, and we need to store the contact number as well. So I'll do new student, and now you can see contact number as well, right? We need to provide this contact number information based on this. So basically extending is about creating using an existing interface, but if you don't want to change that, and if you want to create a new interface, then this is how you use basically extends, and then similar way. Now similarly, how you would do that in type alias is using AND. So instead of having a keyword called extends, what we'll have is type a new, we'll give a new type called new tstudent, and then we already have an existing type which is tstudent, and then I'll use section this symbol, this operator called ampersand, and then I will say I need a contact number. Again, similarly, if you look at here, since this student 3 is a special student and that requires contact number, and we assigned a new type called new tstudent, you can see it's expecting contact number to be there. So the difference of how you would extend an interface versus keyword for a type alias is interface expects extends and the existing interface, whereas type alias we use something called the intersection or the ampersand operator. And in here you don't actually have to have this on the front. What you can do is you can do this as well, which is, and it basically does the same thing. You can have it either in the front or in the back. Open versus close. Okay, I don't have an example here. So open versus closed is mostly about, or actually let's see for the type first. Let me comment out this here, and I'll do it here. Right, so we have a type alias here called tstudent. Since I mentioned that type alias is closed, that we cannot now say tstudent again and say and try to define something else. Again, let's say it's the same thing, contact. It doesn't allow that. We cannot do that for type alias. However, for interface, so you see, we don't get any error like this one here. even though iStudent is already here defined somewhere in line 63, I have defined an interface called iStudent, and down the line I created the interface with the same name again, and it doesn't give us any error. So we can actually declare. So the declaration merging is about, now let's say contact number is number. So what it does is, if I define another interface with the same name and have some new types, it declares those two interfaces. So if I come here and say let student 7 or 8 is iStudent, you see we have contact number here, right? It's coming from this student iStudent, and the original interface doesn't have that contact number, but still we see that here it expects contact number to be there. So this is what open or declaration merging means. So basically, into TypeScript merges, if there are two interfaces, then it merges all its keys together. This is mostly useful when, let's say, you have a you're working with some third-party library or a package, and they already have some kind of interface, and you don't want to create a new interface by extending it as we saw before, but then you want to use the same name, but then you also want to have some kind of custom keys there, right? So this is how you can do it. You basically say something, and then you give some keys there, and it merges them together. So these are the differences. Right. So another useful thing in TypeScript is about enums. Enums is basically grouping the related constant values together. So for example, we have direction. So direction can be up, right, left, or down. So the way we would use is keyword called enum, the name, similar to how interface was written, looks very similar. Enum, the name, and then like an object, but then you have is equal to, and then you can assign that value here. So the first one is something called numerous. If we actually log the value of resource type dot book, then we get value I think 0. It starts with 0, right, Gesundai? Gesundai is here. Yeah, thanks, promise. So they're starting with 0, so that's a numerous enum. The second one is string, where you defined a string for a given key. So let's look into that as well. Should be index 6. Yeah. Yeah, so we have before even that, I probably want to show, yeah. So for example, in the previous, let's say we're writing a lot of student objects. And for a country, we always need to go and type specifically, right? Is the student from Nepal, or is the student from some other country? But the better way to do is, because these are constant values, we know that there are some specific countries. What we can do is we can put them in an enum, right, like this. So enum, you give a name, this one, and what you can do here is, so instead of directly assigning because this is just a string, right? What if you mystically say I, right? But then our probably API or somewhere we are just expecting only Nepal. So in this case, I can use that enum called countries dot, and then I can also, the benefit here is you get that intelligent thing from VS Code and TypeScript, and then you can see the values. so you don't have to type like an string by itself. Let's say for color, let's say we have red in capital, green in capital, and blue in capital. Everything should be in a capital color. So what I can do is I can create a enum, give it a name, red, and then I can assign some specific constant. So it should always be red, it should always be green, and it should always be blue. So if I come here, and then rather than, well, we were actually expecting it to be this, but then we probably make a mistake. We probably create a proc, and then we say small ret. Now that might break somewhere in the code. So to avoid that, we can say color dot red, let's say. Now if I even see here, this always points to red with a capital, everything uppercase, red. So this is and let's imagine this color, that red, is being used in many places. So rather, if we hadn't used some kind of enums and had something like this, and let's say we want to change the color, or change the spelling somehow. So instead of having red, we want actually to be also say reds. So if this thing was used in 10 different files, or in a lot of places, then we would have to go in each place and then change this value. But having the benefit of, or using the benefit of enums, is that color dot red. So if I come here and then if I change only at one place, this will be reflected in everywhere, right? So this is also another benefit of enum. Yeah, I think that's mostly it for enum. Yeah, so it makes your code more readable with descriptive constants. And lastly, it's about utility types. So there are some helper types from TypeScript that helps you to transform your types itself. So for example, partial, required, omit, pick, read only, exclude, return type. Let's look into those as well. I think 7. Okay, so what I'll do here is I'll say, where is my interface? Seven. And let me remove this for now. Why? Maybe I'll yeah. So okay, so first of all, let's imagine we have a interface called student, and how we would use different utility types like partial, required, omit, pick, a lot of these things is let's imagine a scenario where we're not trying to pass, we're trying to make an edit, right? We're trying to make an edit. There's an edit form, and then we have input fields where we can update name and address, right? So just name and address. So in the backend, in the API, what it expects is it expects just the ID, name, and address. It doesn't expect is enrolled, it doesn't expect enroll date, and it doesn't expect subjects. So one way we could do that is probably create a new interface, say for student update, let's say, and maybe we can have only this, right? So this means, so let me declare, and now say, let's say this is student 10, So what are we? Since this is string 10, we're trying to make an edit to string 10, and the only values that we need to pass to our API endpoint to make an edit is just an ID, name, and string. That's why what we did was we created a new interface, and then we can pass here. So now it says, okay, give me only these things: address, ID, and name. But with the help of utility types, what we can do is we can instead avoid writing all this by ourselves again. So what I'll do here instead is I still need to create a new string update, but what I can do is I can say extends string, but okay, I don't need this for now. So there's a thing called peak. So what peak basically does is I'll pass peak here. Oops. And then so I'll use a utility tool called peak, and it expects two different things. So with the inside the angle bracket like this, so peak angle bracket, I'll first pass the student because that's our already existing interface, and comma, and then one of the things from here. Let's say for now probably I need only name, right? Let's say I just need name. Now this interface, I don't need this, but I still need to have at least this empty bracket. So if I come here now, because we have already given a type string update to be string 10. Where did it go? Oh, sorry. Yeah, thank you. See, now you can see here it expects only name here, because we said from the existing interface called string we wanted to pick only name, right? So we don't actually have to go, as in the previous example, we don't have to go and write name ID again. What if I want, like following the previous example, let's say we want this top 3. So what I'll do here is not just name, I will also need ID. So what I can use is if you remember from the union type, we can use vertical pipe. So here I'll go and say I need ID as well. So now I can't, sorry, let me actually pass something. So it will complain now because I'm not just expecting name, I'm also expecting ID. So ID is probably 1, 2, 3, right? So this is how we can use pick to pick whatever the things we want. Let's say for now we also want address, and we'll get an error saying we need address as well here. So I'll go address and then say now similarly, what do you think will omit do then? Sorry? Yep, exactly. So it's just the opposite of pick. So instead of having let's say instead of the 2 for now, and then I'll just say omit, and I'll pass this with 2 now. Now we're getting error because what we did is instead of saying I want to pick name, ID, and address, we said from this omit this 3 and give me the rest. So it will actually, so if I go here and do this, yeah, you don't see the ID, name, and address, but you see the rest of them, which is enrolled and is enrolled and subjects. Similarly, anyone partial? What does partial do? Yeah, you can make a guess. Yeah, similar. Half optional. We can say it as an optional. you know how before we said we can assign, we can do this, use this question mark to say that out of this enroll date can be either a date or undefined, so it's optional. But now let's say if we use partial here, so I don't need this. Student update 3. So you see all of them, but then they all are optional, right? So it's up to you if you want to pass just the ID, and that's fine. It won't complain to us because what we have done is for this student update 3 interface, we made that everything out of this can be partial. You don't have to pass all of it. It's up to you. Anyone? Then should be very easy now. Yeah. So this one is exactly just the opposite of required partial. Sorry. And then what happens is, let's say out of this we said we have a, let's say this is our original interface, which has these 3 to be optional, but then somewhere down the line we need to pass everything, then we can make this as a required. Then what happens is here, then you don't see that question mark for whichever the keys were optional, but then you see all of them to be passed. So that's required. And it's not just for the these are all the utility types that we just see here. I mean, some of the few utility types. It's not for the interface only. You can do the similar thing for type as well. And the way we do it is very similar. So for example, we have student update 5. Right, so student oops. Yeah, we are right now we're just passing the original student interface to a type. It doesn't always have to be type and type or interface and interface. You can actually assign this interface to type as well. So type and interface are interchangeable. You can use them. You can actually extend an interface with a type as well. So here, and we can say, the way we showed before. So contact, let's say, number. We're creating a new type alias, but then we're not extending a type. We're actually extending an interface. So this is possible, and it's vice versa. You can do the same for interface as well. You can extend a type, but the thing that I wanted to show you is just, let's say, partial. Yeah, so this is not just for interface. It works the same way for type alias as well. And now if you look at this, everything is optional. You can pass some of the types, for example number, whatever, or it's optional and it will be undefined. So these are just some of the things that we use mostly. There are a few other, like return type, extract. That's from the official TypeScript documentation. You can find more about them. And lastly, so this is what happens if we use any, right? Whatever we learned, all the basic types today, we'll make our code very, very safe, very robust. But at the end, if you keep using any, this is what happens. So thank you. Any questions? You wanna? Yeah.
Yes, amazing. Thank you, Sona. Any questions? All right. Yeah, I've got one question.
Yeah.
So when do you know when to use the type alias or we communicate?
Yeah. So that's
Yeah.
Oh, you do you want it? Did you want to take it?
Right.
I mean, for me, obviously there are few scenarios where you absolutely need to use type alias. For example, if you're dealing with primitives, because you cannot do that with interface. Interfaces are solely for objects to define the shape of an object. So in that case, you have to do intersection. I mean, if you're especially dealing only with primitives, then you can't use interface. So in that case, obviously you will have to use type alias. But if you when it comes with objects, it's mostly up to you. This is a preference. Some people coming from, let's say, background, if they have done C#, mostly Java, they probably had worked a lot with interface, so they're mostly they keep using interface. So for me, I personally like type alias, but that doesn't mean that it's always the best. Yeah, it's mostly the preference, whatever you want to do.
Yeah, and also if you have to give a type to your class, then you have to use interface. You can't use type. So for classes, interface is. So you have to use interface. So it all depends on your application. Any other?
So any other